Good morning. This recording is for Algebra 1, Chapter 4, Lesson 7. And I have a quote for you today. Hold on. The recording, as always, comes from Horseradish, Bitter Truths You Can't Avoid by Lemony Snicket, page 105. Love can change a person the way a parent can change a baby, awkwardly and often with a great deal of mess. Okay. Onward. Inductive and deductive reasoning. You guys are probably very familiar with these. You've heard these words before. Inductive reasoning is making conclusions based on patterns you observe, and the conjecture is the conclusion you reach because of inductive reasoning. So if like, I can only think of like a serial killer in mysteries, but that's because I'm a big murder mystery fan. Anyway, so if you see a pattern and then you figure out what the next maybe number is in a pattern, then you have made a conjecture. Okay, so let's go ahead and use inductive reasoning to describe each pattern, then find the next two numbers in the pattern. So here in the first one, we've got 3, 9, 27, 81. Well, what happens to go from here to here? Well, that was a multiply by 3. Here to here, it was a multiply by 3, and here to here was also a multiply by 3. So we're going to multiply the previous number by 3, which means, I don't want to have to do this mentally, we're going to do 81 times 3 to figure out the next number in the sequence, which is 243, and then we're going to multiply that by 3, and we're going to get 729. So those are the next two numbers in the pattern and the pattern itself. And so basically we've made a conjecture that the next two numbers in the sequence are 243 and 729, and that again the pattern is multiply the previous number by 3. Okay, next one we have 2, -4, 8, -6. Well, to get from here to here, we would have to multiply by 2. The only thing is we're going from positive to a negative, so maybe not necessarily multiply by 2, but multiply by -2. And that one is also a multiply by -2, and that one is a multiply by -2 as well. So I guess the pattern is, multiply previous by -2. And so the next two numbers in the sequence would be -16 times -2, which would be a positive 32. 32 times 2, but it's a -2, would give you -64. So those are the next two numbers in the sequence. Okay, moving on. Writing a function rule to describe a pattern. We're going to write a function rule that gives the sum of the first n positive odd integers, where n is the natural number, then predict the sum of the first 20 positive odd integers. So let's go ahead and start off and see if we can figure out a pattern. Well, the first odd number that we have, that is a natural number, meaning that it's positive, is 1, right? 1. And then we also have 1 plus 3, which would be the first two positive odd integers, and then 1 plus 3 plus 5, and then 1 plus 3 plus 4 plus 7 is up to 4 positive odd integers. But is there a way that we can look at this? 1 is another way that you can say is like 1 times 1 is 1 squared. Well, this is going to give you 4. Well, 4 is the same as 2 squared. 1 plus 3 plus 5 is 9. Well, that's the same as 3 squared. Are you guys seeing the pattern here? Where the first integer is 1 squared, the second two integers are 2 squared, and the sum of the first three odd integers is 3 squared. So maybe we can even keep going, and this would be 4 squared. Well, let's double check. 3 plus 1 is 4, plus 5 is 9, plus 7 is 16. Yep, 4 squared equals 16. So if you guys can see, it's the number of integers, odd integers, that we're adding. That's kind of that would then give us the final answer. So 5 integers would be 5 squared, which would be 25, and all the way down to 20 would be 20 squared, which I'm going to need to pull out my big calculator for that because I don't want to have to sit here and do it for you. So that would be 20 squared is 400. So the answer is 400, but they also asked us to write a function rule. A function rule. So how are we going to describe this in numbers? We've basically figured out the pattern, but then now we need to figure out how this actually works. So basically we could say that the sum of the numbers, where s of n is equal to them all added together, and you could say it's the sum of the first n positive odd integers. I spelled that wrong. Integers. There we go. Too many R's in there. All right. So we need to actually figure out what this is. Well, if we're to look at the odd integers, we're basically figuring out where we're starting, and then it's basically going to give us n squared. So the sum of the n number of odd integers is basically equal to the number of odd integers squared. All right, so there's your function rule. All right, so if this is kind of like your set builder and your what's going on. All right, because it describes the pattern, but then it also gives you a way of looking at it. So if n is the number of odd integers we have, well, if you add them up, the number of odd we have squared is going to give you the final sum. Okay, moving on. Alrighty, so let's go ahead and look at this pattern because I need to give you several patterns. So we need to write a function rule that gives the sum of the first n positive and even integers, where n is a natural number, meaning we're starting positive, and then predict the sum of the first 30 even positive integers. Well, the first even integer we have is 2, which was the same as like 2 times 1, or 1 times 2. 1 times 2. Okay, and now we have 6. Well, that's like 2 times 3, right? And then now we have 12, which is the same as 3 times 4. And now we have, so that's 6 plus 6 is 12, plus 8 is 20, which is very similar to 4 times 5. So you guys see how we're kind of increasing each time? We've got 1, 2, 2, 3, 3, 4, 4, 5. So the next one will probably be 5, 6. 6 will be 6, 7. 7 will be 7, 8. So basically, it's the row that we're on plus one more row, and that's basically what we're multiplying by. So if we need to get to row 30, it's basically going to be 30 plus 1, which would be 31. And so how we're going to write that is the row n is equal to n times n plus 1. And that's basically going to give us the sum. So if we have basically the sum of n, well, that's going to be n times n plus 1. There we go. Alrighty. So if we needed to do 30, again, it would be 30 times 31, which would be that on row 30, the sum would be 930. Okay? So then, again, that's this is the function rule. All right? And you've got to figure out, based on the pattern, what's going on. It's very important that you get used to learning how to figure this out. Think about how things are adding, things about multiplying, adding, subtracting. Think about exponents. It's totally important. All right? This is something that's going to come in handy a lot later down the road, but it's good to start getting used to it now. Okay, last thing we need to talk about is deductive reasoning, the conclusions you make based on given facts. So like you could say a cop does this because based on the facts, the person was wearing a size 5 shoe, okay? Whereas inductive reasoning, we would be like, again, I can only think of like murder mysteries. Let's say a a serial killer has only killed, Cheerios, so maybe the serial killer, the serial killer will only kill Cheerios later in the past, and those poor cornflakes are okay. All right. So deductive reasoning was that the serial killer, used a soup spoon to eat their cereal. Because we found a soup spoon at the scene of the crime, whereas the pattern is that every time they've eaten Cheerios, so next time they're probably not going to eat cornflakes. Okay? All right, so there's your difference between inductive and deductive reasoning. All right, so explain whether each situation represents inductive reasoning or deductive reasoning. At a football game, you notice that all the students from the opposing school are wearing red and blue. You conclude that the school's colors are red and blue. Well, if this is something you've noticed, basically you don't know that the school colors are a fact, but from a pattern where all the students are wearing this, you can say it's inductive reasoning. Okay, because based on the pattern, you kind of just assume that's their colors, right? Now, the next question is, you solve the equation x minus 5 equals 2 by adding 5 to each side. You conclude that the value of x is 7. Now, this is based on a law of math. It's a property of math. So since you're basing it on a property, properties are pretty much fact because they hold true every single time. This is what we call deductive. Okay? And the last example is you conclude a person is at least 16 years old because he or she has a driver's license and you know that the legal driving age is 16. Well, we're basing this on a law. Since we're basing this on a law, it is what we call fact. Therefore, this is also deductive. Okay? All right, hope you guys have a better understanding of deductive and inductive reasoning, and I'll talk to you later. Bye.